The 2022 Nobel Prize in Chemistry has been awarded for click chemistry and bioorthogonal chemistry. The three laureates for the award are Barry Sharpless, Morten Meldal, and Carolyn Bertozzi for their contributions towards click chemistry and bioorthogonal click chemistry. So what is click chemistry? Barry Sharpless originally coined this term around the year 2000, and this was a reaction that was independently discovered by both Sharpless and Meldal. Click chemistry is well known amongst contemporary chemists as typically being a reaction between an alkyne and an azide. The nice thing about this chemistry is it's extremely selective and it requires only a small loading of copper-1 catalyst. The products formed from these reactions are called triazoles. This is a useful reaction because you can imagine that alkynes and azides aren't something that are typically found in a biological context, although the requirement of copper as a catalyst was somewhat limiting for this approach. Now that being said, this type of chemistry can be really useful for building quick libraries of different compounds in the development of new pharmaceuticals or biologically active agents, and many labs look at this as a method for generating rapid libraries of compounds. This can also be used bioorthogonally, which is where we get to the third laureate, Carolyn Bertozzi. Her group developed a procedure that combined sugar chemistry to couple a sugar-bound azide with a glycan present on a cell membrane so that an azide could be installed in a biological context. Now, to get this process metal-free and avoid the use of copper, it was necessary to use a strained cyclic alkyne, which was bound to a fluorescent tag. The nice thing about this is, because azides and alkynes aren't usually found in a biological context, there might be some examples of alkynes, although they're extremely rare. This is a really selective reaction that's able to take place really cleanly. This type of reaction is called a 3+2 cycloaddition reaction. When this cycloaddition reaction occurs, the strain of the alkyne is relieved, and this is the process that drives the process forward. This has been used, for instance, in the fluorescent labeling of cell membranes, and it's a widely adopted technique in the modern era. There's other variants of click chemistry that have been reported, but these weren't recognized in the selection of Nobel laureates for this year's award. Some other processes include the generation of high-energy carbines, which can be used for proximity labeling, through the generation of carbene or carbenoid type intermediates. Although in this case, this is the preliminary fundamental work that really led to the development of this whole field. So some quick fun facts for you. Barry Sharpless actually already has one Nobel Prize, and this is his second Nobel Prize. He's the third person to receive a second Nobel Prize in his field, while he's only the second chemist to be awarded a second Nobel Prize in chemistry, the first of which being Frederick Sanger. It's also worth noting that Sharpless and Meldal both independently discovered the copper-1 catalyzed click reaction within a short period of each other. The original term, click chemistry, was coined by Sharpless around the year 2000. So hopefully you've enjoyed this, and I'd like to congratulate the laureates for being recognized by the whole community for their contributions to the field. Thanks for watching, and I hope you have a great day.